Okay, continuing on. So this Newton's law of cooling problem. It says a hard-boiled egg is heated to 96 degrees. So that is the temperature of the object. So that we know is 96. And we're put into a pot of cold water of 16 degrees. So we know that's the temperature of the material. So from our model, then, we have this, but we have an issue because we don't know K or T here, right? We don't know K, so how long to find something, we don't have that information. However, you'll notice it says after 4 minutes, the temperature of the egg is 45 degrees. What that tells us then is the temperature, T of T is 45. And we'll just make 96 minus 16 is 80 after 4 minutes. So we can now solve this equation for K. So we'll subtract 16 from both sides. So that's going to be 29. And then we'll divide both sides by 80. And then to get rid of the exponent base of e, we'll have to use the logarithm base e, which we remember is the natural log, ln. Do that to both sides. So we have that, and then we just need to divide both sides by -4. So we have that, and we can now type this into our calculator. 1/4 times the natural log of 29/80. So that is about about 0.254 for K. Now that we have that value for K, we can use it to solve the other part of the problem. So we need this. So what our new model says is that T of T is equal to 16 plus 80e to the -2.54 T. And we want how long will it take for the egg to cool to 20 degrees Celsius? So we're just going to plug 20 in. And then we're going to solve this equation for T. So we'll start by subtracting 16 from both sides. And then we'll divide both sides by 80. And then again, we have to cancel this exponent base of e, so we'll do that by taking the natural log of both sides. So the log base e will cancel exponent base e. My last step will be to divide both sides by -2.54. Okay. So it's calculator time now, so I'm going to do -1 over, and I'm just going to take this answer, so second and ands, times the natural log of 4 divided by 80, and press enter. So I get about 11.81 minutes. And that should be that.